Okay, so hi and welcome back to the Programming Bootcamp. My name is Gabor Sabo. Hi, Nora.
Hi.
In this episode, we are going to talk a little bit outside of the actual scope of the basics of the program, but I really wanted to show you a little bit about testing, because I think it's a very important tool in programming to ensure that your code is correct, not only now but only later. And this has to be clear. So in software companies or all these companies, there are many places where they have a QA department or whatever, quality assurance, that they are supposed to check whether your application is correct. And the problem unfortunately is that you have a version and they sort of check it now, but then if you change anything, in order to make sure that everything still works, they should check everything again. And they usually don't do that, of course, because it's way too much time and way too many people would be needed, and too much, whatever, would be too costly. And there is something which we call automated tests, and that's what I'm going to show you, how to write tests that are automated. And then people have this feeling that just as the QA system, that are the QA people that are there to find bugs in our program now, the tests are there to find bugs in a program now. And this is actually only a minor part of them. The major part is to ensure that when you change the code tomorrow or a week from now or 3 years from now, you don't introduce some bug in an area that was already working earlier, which we usually also call regression testing. So there is no regression in your code. So the real value in these automated tests is going to happen later on. And I just recently saw about this explanation, someone saying that the biggest misunderstanding about this explanation, when we say that test automation is for the future, for long term, is that what long means. For me, long means about 2-3 hours. And then it's already starting to pay off, because I'm making some changes, I'm writing some program, some part already works, and then, or I check with a couple of values, let's say, and it works. And then an hour, 2 hours from now, I found some other input, let's say, that with that input, it didn't work. So I want to fix it. But now, in order to make sure that I didn't break the earlier ones, I have to go over all of them again. And if I was doing it manually, very quickly I would abandon that. And very quickly I won't do that, because it's too time consuming for myself alone. But if I invested the time to write these automated tests, then it's just a click of a button and a couple of seconds of waiting, okay? And many people think that the long term means months or years from now. And no, this is usually days or even hours. So maybe the explanation should be changed. Okay, so let me share the screen. This is not what I wanted to show. This is what I'm going to show. And in the slides, there are a couple of chapters about testing, but specifically I'm going to show the testing demo, okay, which I wrote especially to demonstrate how to write tests. And I'm going to demonstrate three different ways of writing tests, okay? And I won't go deeply in any of them. And the one that I'm going to show at the last one, this is the one that I'm really recommending. And then this is where I have like a 2 or 3 days long course just for that, to go deep and how to use that for various interesting things. So usually I start if I just show this, is to asking, okay, what kind of programs you write? But we know that what kind of programs we are writing in this course, and how can we test it? Okay, so these are these command line programs for now that already have modules, already have functions and modules. And all these functions, what they do is get some data and then return some other data. So we don't have these databases and web application for now, but at the end, they would be the same. We would just have to find a way to access those things. But at the end is something like this, okay? So what is testing is we have what we call a fixture, which I have no idea if it has any other meaning than the one I know. So maybe it has all kind of other meanings. So fixture in our sense means the world as it is before we start running the program. So maybe in order to run your program, you need a file. So preparing that file is the fixture. Okay, so just to have a simple case. Maybe your program assumes some directory structure. So you need to prepare that directory structure before you run the program. And in larger applications, you would set up a database with some content in it, some computers maybe to already do things separately, a web server, all kind of these things. But in the small case, it could be just having a directory structure, a couple of files in some format that you need, okay? And then you run the program. The program gets some input, okay? This can be other files or just input from the user. And then you get some expected output, okay? This is basically the test, okay? We have some world, some situation, we do something with the situation, and we expect something. Okay. The reality, however, is that this is what we actually have. Okay. So we have all the input, all the things, but we have a little difference, which is the bugs, all the bugs. Okay. And this is basically what we try to make sure that we notice when there are bugs, when there are issues coming in. So there are going to three tools. One of them is called doctest, one of them Unittest, and the third one is called pytest. There is something called AUT usually, which is application under test, which is like just a big name for the function that you would like to make sure that it works, or program that you would like to make sure that works. Okay, and what we are going to see is going to write a test for your application that's passing, so it's successful, and also one that's going to fail, so you can see how it looks like when it fails. Okay. And just by the way, do you see the timestamp here? That's from the previous video, and you're talking about date time. So this is what created from this date time. Okay. This is the
nice.
This is the microseconds I can see. So probably I have to shorten that. Okay. So this is the application that we are going to test. Okay. It's just a module that has a function in it. Okay, the function is brilliantly called add, gets two variables, and then returns the sum of them, or so I thought. Okay, and yes, I know there is a bug in this program, and there is on purpose, so I can show both success and failure. Now you can of course imagine that you have a bigger script function that works on various inputs, but doesn't work on other inputs. Just an example, DNA, okay? You have a DNA sequence with the 4 common letters, and then maybe you also accept X as a placeholder or whatever. And that's how you wrote your program. But someone brings in a different sequence where they also use Y, or they use Y instead of X, just to represent the garbage, or for some reason, and then your program suddenly doesn't work, right? So that's why I'm saying that you had some assumptions and use that, and maybe someone brings some other data, not just bugs like this, but this can also happen. I mean, in a huge application, it calculates something, and you know the result for the first 5 numbers, and you didn't check the 6th because I thought, okay, the first 5 works, then maybe everything works. Okay, so there is, I don't know who's saying is that you can never prove that a program works, that it's bug-free, okay? Because you can't check all the possibilities. So how do we test this, okay? So first of all, how do we use this program? Okay, just you would use that module. So you would import it. Okay, it was called mymath, right? mymath.py. So you would import it, and then the program would get some input from the user, and from the input, then we would call the function add, get the result, and print it out. So this would be the normal usage. So if I wanted to test it manually, I would write a script like this, run it with a couple of inputs, and check if the output is what I am expecting. Okay, so if I run it 2 and 2, and then I get 4, so it works, right? It's correct. So this is what we are going to do now. Just we are going to write tests for it. The first test is what we call the doc test, and we had some slides with it, but I mostly skipped them. I think we had the exercise left over and I skipped the slide. So if you have a function, you can put a comment immediately after the declaration of the function, and this is going to be the documentation of the function. That's nothing to do with doc test yet. You can in this explanation, in this documentation, you can write things like this: 3 greater than signs, and then some code. Okay, do you remember when we saw this 3 greater than signs?
When Python's running in Anaconda, that's
in the interactive
shell, yeah.
In the interactive shell. So basically, if I run here Python, then this is the interactive shell, and here now I can say 2 plus 2, just to be in the same. And if I didn't put the space at the beginning, then it would actually give me 4. Okay, so now if you look at this, this looks like an interaction with the interactive shell. So here in the example, I wrote exactly the same. I had some interaction. I called the function, the add function, and I put here what is the result. Now, this is a really good documentation, because the user who reads this documentation and wonders how to use this add function can already see, okay, I can give it this number, and then this is the result going to be. But because it looks like an interactive code, you can actually ask the doctest module in this way to run these tests, to check these examples. So if you run this Python -m doctest, this loads the doctest module, and then you give it the mymath code. Okay, so now I changed the original code. Okay, then what it will do, it will find all the functions. In this case, there we only have one. It will read the documentation of it. It will notice that there is an interactive prompt, something that looks like the interactive prompt. Then it will call this function, get the result, and compare it with the value that here. And because these are equal, it will not print anything. It's a bit confusing, but it doesn't print anything. Okay, then did I mention that every program has an exit code? Yes, I think we talked about it a little bit, right?
Yeah.
So, and that in Unix it's in the $?, and in Windows it's in the error level. Okay, so because this program, this execution was successful, the error level is going to be 0 on Windows, and in the $? on Linux would be 0. Okay, so let me try to run this if I'm already here. So I exit this one, and this is in the testing demo, and inside there is doctest first. So I can run Python -m doctest, right, and then mymath.py. Okay, nothing printed. But if I print out the error level, then it says 0. So from this, I can know that it was successful. I mean, from both. Okay, but then someone comes in, of course, and starts complaining. Yeah, said, yeah, I tried it with 3 and 3, and it didn't give me what I expected. It didn't give me, what did I expect? 6, right? So 3 plus 3 should be 6. So I'm saying, okay, I don't really, I mean, okay, the person said it doesn't mean anything. Maybe they were mistaken. Maybe they use it incorrectly. So I'm going to add this test case to my documentation just to prove that they were incorrect. And so it's in the doctest fail directory, this example. So doctest fail. And here I can run the same program, and this is what I get. Okay, so here I get a failed example, add 3, expected seed got 9. Okay, and more information. And if I run this echo thing, but Windows, of course, forgot it. You know, it's here. Now it's 1. So it's not 0. That's the whole point. Okay, so yeah, I can also check this, but I also can see that, oh, there is output, and that means that there was a failure. Okay, and yes, we know that there is a bug in the code, and that's why it fails. But now you can see that both the success and the failure. And then you would go here at this point and say, okay, so there's the bug. I'm going to check what's the bug. I'm going to fix it. But now I already have a test case that verifies that both the previous thing still works and the new one. Okay, and if more people, and if you might think about some extreme cases where you might think, okay, this might not work, then you can add all those examples here, and you can when you run it, they will all be checked all the time when you just run it. Okay, and the nice thing is that the tests are built in. They also are documentation. You actually also test whether your documentation and your actual code aligns, which is one of the hardest thing. Many times people say don't write documentation because even though it might be correct now, but then later we change the code and the documentation will not reflect the code. You can't do this here because you actually test whether your documentation reflects the current implementation of the code. Okay, it might still be that. So if I now had written here 9, it would be nicely passing, and then I would be verifying some incorrect behavior. Okay, so the fact that we have tests doesn't mean that the code, and even the fact that the test passing doesn't mean the code correct, because the tests can also have bugs. But tests are usually much more simple, especially if you say, okay, this is the input, this is the expected output. If I don't know what is the expected output, then I can't expect the code to work properly anyway, right? So this is the most simple way to write tests, and it's built in, so it comes with Python. The big drawback is that you really can't test anything complex with this, only single functions, okay? But for that, it's really good, okay? The next example, I'm going to use the module which is called Unittest. Now, this is a little bit confusing for people who are coming from programming background, because the meaning of Unittest, it also has a global meaning or a generic meaning. Unittest means testing small units of your code. And then we also have words for integration tests, where you have combined multiple of these units and then you test whether together they work. And then all kind of bigger words testing more complex parts. But this library is just called Unittest, okay? And it has nothing to do with that. So you can write Unittest with it. You can write more complex tests. It's just, that's the name, okay? So that's why I'm saying it's a little bit confusing. And so how do you use this? So now for this, I need to write a separate file, which is called test something. And in this file, I import the Unittest package. I import my module that I'm testing, okay? And I write here, we haven't learned about classes, so just, this is how you write it. So you create something like this class and then test something. And here in the parentheses, you put Unittest.test case. For people who understand a little bit classes, this means that we are inheriting from this class. Okay, so the class system is an inheritance system, like in biology or whatever, maybe not. It says that all the features that this has, we also have. We inherit all the features. Slightly different. Okay, so but we must call it test something with this capitalization. Okay, what doesn't matter. So you can call it test kukuriku, but it has to start with test. And then inside you have to create functions that are also called test underscore something. Okay, all this naming is critical because that's how the testing libraries can find which is a test class and which is maybe just a helper class. Okay, so maybe for the test you need a separate class just to help, or maybe these functions you have a couple of test functions, but you also need helper functions. Okay, so that's the reason to separate them. And then inside the cell, there is this self, which is just a representation of itself. Okay, and then you write something like this: self.assert equal, and then here inside you have the actual result. So we code the code and we get back the result and the expected result. And then assert equal checks whether the two are equal. So it's a little bit similar to the assert that we mentioned, but it's very specific to this module, the unit test module. And there are all kind of other asserts, like assert bigger than, or asserts contains, or all kind of these things. Okay, but we don't go in there because that's way too much involvement. I just wanted to show you the basic things. So this one will check whether this call returns 4. And how do I run this? I run Python -m Unittest and name of the test file. And it won't print anything either, but the exit code will be 0. Both here and, oh, actually, no, sorry, wrong answer, wrong, it will print something like this, okay? But the exit code will be also 0. And I forgot to put the error level here, but the same. So it's called test1 with Unittest. So I say Python -m unit test, and then the name of the file is test1 with Unittest, this one. Okay, so this is the output because it was successful, and echo error level is 0. And what you can see here, this little dot means that there was just one test function which was successful. And then you also get it in words or numbers. But this dot represents that test function, the test math. Okay, here too, of course, people complain that still doesn't work. And so you can come in and write another test function, for example, that just some other name, and then assert equal again with 3 and expect 6. And if we run it now, then you will get this output. So here, and the error level is 1. Okay, so it's called test with Unittest. With where is it? Unittest, this one. So you can see here the error level is 1, and what we can see here is that .f. So the dot means the one successful test, and the f means the one failed test. And you can see the details about the failure. And you could put this statement inside the same function. So in the test function, in a single test function, you could have multiple of these assertions. The advantage, of course, you don't have millions of test cases. The disadvantage is that if you have, let's say, 10 assertions and the third one fails, then the rest won't be executed. So you won't know if all those are successful or some of them would fail, because the first assertion just stops that test function. On the other hand, if you have several test functions, then they are independent. So if one fails, all the rest are still running. So you would get all the failures and all the successes. So it's sort of a trade-off. Usually the recommendation is that if you test things that are really depend on each other, okay, compute this, then compute this, which depend on each other, then put them in a single test function. And if they are independent, then put them in separate functions. Anyway, here too, of course, at this point, you would probably go and fix your code. Okay, fix the code. But again, you would keep then this unit test, and later on you can run it anytime and verify that now both are running. So if someone comes with a new case where the program doesn't work, you can just add it and run it again and see, oh, the previous one still work, the new one fails. Now I go and fix it, and my fix must work for all of them. So, okay. Last type, which is called pytest. Pytest is a separate package that one needs to install. Maybe it comes with Anaconda, but in general, you have to install it. But this is the most popular and the most powerful way of testing. It's really way more powerful and way more popular than the Unittest package. How do you test it? So the default is that you don't even need to mention pytest in this code. You just write some code that uses the original thing. Now here in this one, I also used classes. So I have say class. Here too, you have to use test something and a test something function. And the file also needs to be test something. So the naming convention is the same. But inside here, you don't need to remember all these special assert equal and assert less than and all that. You just have assert and any regular Python comparison. Okay. So here in this case, I just run the function and compare if it returns 4. And how do I run it? I type in pytest and the name of the file. And again, this prints out something. Here you can see the dot similar, in a way similar output. So this dot means that this test function was successful. And some generic data, and the error level is again 0. Adding wait a second, yes, adding another test case, here test, same thing, just another separate test function. Okay, with 3, 3 and comparing to 6. And this fails, so the error level is 1. And here you can see dot and f, and you can see the details. Okay, so now, I mean, from this, you can't really see that it's way more powerful, of course, because this is really a basic example. So you might trust me on that or not. But I would be really happy if you started to write any test, doesn't matter which one. Okay, just start writing tests for your code, because that also helps you write better code, and also makes it easier to verify that future changes don't create new problems. Okay, so there is actually an easier way to write these pytest modules. You don't need the classes. You can just write functions. Okay, so this is the same, just without the class. Here too, by the way, you could put 2 of these assertions or more in a single function, with the same issue that the first one in a set of assertions stops that test function. And the nice thing with pytest is that you can say pytest minus doctest modules and give it a file name, and it will run the doctests themselves as well. So if you started with doctest, no problem, the pytest can run them. You can graduate to start pytest. Same with Unittest. You can run pytest, name of a Unittest file, and it can run it. So if you start writing doctest because you like them and it seems simple, no problem. Later on, you can still use pytest and still run those tests. And you have documentation as well, so that's nice. Unittest, I would less recommend it, but if that's what you'd like, then go ahead and use that. Okay. And I see that there is an exercise here, but in general, okay, before the exercises, any questions?
Not for now, no. I mean, obviously, I'm going to have to start using it.
Yeah, that would be a really good idea. Yeah. So there is this exercise just to test anagrams. Okay. So an anagram is two basically strings that contain the exact same set of letters. So in this different order. So listen and silent are anagrams, and bad credit and debit card are anagrams, which are these funny ones. And there are a couple of others. And so this is my solution. So now the test, the exercise here in this one is to write a test that is successful, then write a test that is failing. So come up with an anagram that fails on this one. Okay, and you can play around with each one of the test modules. That would be the exercise in this one. This is just how you would write an exam. How would you use it? And the larger exercise that it's not written here, but that's the more interesting one probably, is now go back to some of your solutions and try to write tests for them. Okay, so obviously for that, the way that we learned how to write tests, you need functions and you need modules. But we also learned in a separate video how to write external programs and capture their output. So even that you could try to attempt that, to take one of your examples, one of your solutions, and run it as an external program and capture its output and see if the output is what you expect. Okay, both could be interesting. So if you still have any questions, then now is the time.
No, I think I'm good.
Okay, so enjoy testing. Do I have anything else wanted to say about testing? So this testing is I think is one of the most critical parts of software development, and it's a lot of people out in the world don't know how to do it, and because they are used to this. Okay, we write the program, and there is a QA department, and they will test it. And I mean, obviously, in the case of anyone in the academic environment, that's not the case because you don't have a QA department. And if you look at open source code, and that could be a nice comparison. So if you write open source code because because you enjoy it, because you needed that code and you just publish it, not because you are a company and want to make money, that's a separate story. But if you do it because of this, then apparently those people write tons of these tests. And they write it because there's no one really to test them. They don't have anyone to test them. That's one reason. And the other reason is that they don't want to do this manual test themselves. That's boring. They don't want to do that. They rather write some more code that will test their program. Okay, so that's what I see. So I go. That's one of the things that I do as a consultant. Go to companies, help them introduce automated tests. And if I look at open source code, it's way more better tested on average, and especially the important ones. So definitely there are lots of open source code that's not well tested. I'm not saying that everything is fine, but the ones that are important, they are usually super well tested. Okay, so I recommend that you also get used to it and learn it, because it's actually really nice to see that everything is passing.
Right.
It gives you something to, okay, go on working. Otherwise, you would just make changes and does it still work? And you don't really know. And that's frightening. Okay, so enjoy testing, and see
Thank
you in
you.
one of the next videos. Bye bye.
See you.